Welcome to Tiny Show and Tell Us, the bonus series where you write in with your favorite science news or factoid, and we read your email aloud and then dive deeper. I'm Deboki Chakravarti, and I'm here with my co-host, Sam Jones.
Hey, Deboki. I'm excited to do another one of these. These are really fun to record. I have a blast.
Yeah.
So before I kick things off today, first, a big thank you to science journalist Ariana Remmel, who did the research for this episode. And second, a reminder that we are always looking for you to write to us because that is what makes future episodes possible. You can email tinymatters@acs.org or fill out the form that's linked in the episode description. All right, let's hop into it. I will go first this time. So my tiny show and tell us today is from listener Matt. And Matt wrote in about a story published in Science about fungus farming ants. And what's so funny about this to me is that Ari, as I mentioned, was the one doing the research for this episode. They actually wrote this story in Science that Matt sent us. So
that's really funny. Yeah.
Yeah, it's a small world here at Tiny Matters. And I was like, hey, Ari, so do you mind just explaining what you did? Anyway, I just thought that was great. So let's talk about these fungus farming ants. How common are they in the ant world? That was a question I had. And so Ari said that Ted Schultz, who's the corresponding author on this paper, told them that there are around 14,000 named species of ant, but only 247 species are known to farm fungi. And these ants are restricted to the Americas. And I was like, oh, 247 actually sounds like a lot. Saying like only 247, that is still a teeny tiny percentage of 14,000 named species of ant.
Right.
But also, ants are not the only known fungus farmers. Termites and ambrosia beetles actually do it too, which is kind of cool. So let's talk benefits. Both ants and the fungi they cultivate benefit from this arrangement. It's a classic example of mutualistic symbiosis. So this is a true symbiotic relationship.
Right.
So the ants will create their gardens within carefully tended chambers of their colonies. And the ants provide their cultivated fungi with substrate to grow on and ensure that their cultivars have everything that they need to thrive. And then in return, the ants get to eat a portion of the fungus. So
that's adorable.
I know. It's like I have a Pixar movie in my mind of this.
Yeah. I watched A Bug's Life.
Yes.
I never saw a fungus farm.
I know, right? Like an ant wakes up in the morning, opens the door to its little cottage.
Right.
And there's this garden of fungus.
Yeah. This is like the new Animal Crossing is going to be like the ant crossing where we're going to just like make a little fungi farm, like little fungus farms.
I love that. Yeah. Okay, we get a cut of that. Whoever comes up with that.
Yes. If you're a video game developer making this game, please tell me and then give us the money.
Yeah, this is trademarked officially. Okay, so fungus farming ants, they don't just cultivate one strain of fungi. And while all fungus farming ants are reliant on fungi for food, not all of the fungi they cultivate require ants to survive.
Okay.
Which is really interesting.
Yeah.
So it's a symbiotic relationship, but it's not always necessary on the side of the fungi, it seems like, which I think is really interesting. Right. So
I mean, I guess like if we think about vegetables, are like is domestic agriculture like considered symbiotic? Are we symbiotic when we do farming?
Maybe because we force them to be in environments that they wouldn't naturally thrive in.
Right.
Like, is forced symbiosis is forced symbiosis really symbiosis?
Yeah.
I guess maybe.
Because, so I guess like what I'm wondering, because like, I mean, like a potato would still grow without us, but
right.
I mean, we can grow without the potato too, but like, it's just not as good of a life without potatoes.
Oh, yeah. Really sadder life.
Sorry, I'm just like loving this overall. Like I feel like I'm gonna keep interrupting you to be like, can we bring this back to weird like hypotheticals?
Yeah. Okay, so I guess fungus farming ants fall into one of 4 agricultural systems, including lower agriculture, where the ants farm fungi that can also be found thriving outside of cultivation. Mm-hmm. There's also yeast agriculture. There's coral fungus agriculture, which, if you want to know what coral fungus looks like, it literally looks like a piece of coral. And then there's higher agriculture, where ants grow fungi that have become domesticated, which means they cannot survive outside of their ant-cultivated gardens.
Okay.
And I guess that these fungi produce fruiting bodies called gongylidea that are a highly nutritious preferred food of the ants. And then I guess Leafcutter ants, which are really famous for harvesting large chunks of fresh vegetation for their gardens, are also in this category of like higher agriculture, where ants grow fungi that have become domesticated, which means they can't survive outside of their ant cultivated gardens.
Right.
So interesting.
That's so cool.
A little bit about this paper that Ari wrote about to make the story that Matt read.
That Matt then wrote to us about.
This is like a game of telephone kind of. But fortunately, we're going like almost back to the source with Ari telling us about it. So the paper was titled The Coevolution of Fungus Ant Agriculture, and it was a Smithsonian Institution research. So the paper was titled The Coevolution of Fungus Ant Agriculture, and it came out in October of last year. Going into this paper, there were some data gaps. So like fungus ant agriculture had mostly been investigated from the ant perspective, which is also very funny. So scientists know a lot more about the evolutionary family tree or phylogeny of fungus farming ants than they actually know about the fungi that they cultivate. So it was like very ant-centric. The fungi were not getting their spotlight.
Yeah.
So part of that is that fungus genomes, I guess, are very complicated, and they require these specialized DNA probes to study. Didn't know that. Yeah, and so researchers needed a mix of ant-cultivated and closely related free-living fungi specimens to sort of map out the family tree of the fungi.
Wow.
And there just wasn't a large enough sample previously. In order to understand how a symbiotic relationship works, you need to not just understand one side of the symbiotic relationship. So what these researchers did was they used genetic data from hundreds of ant and fungi specimens, and then they reconstructed one family tree for the ants and another for the fungi that they cultivate. So the researchers with these two trees were able to figure out the timing of key speciation events on each tree based on when certain organisms appeared in the fossil record. And so that time-stamped phylogeny, so it's not just like this is related to this, but it actually has we have a sense of what date those two things diverged. That time-stamped phylogeny is called a chronogram. And so the researchers then could line up the ant chronogram and the fungus chronogram to see which evolutionary events occurred at the same time, which I thought was really cool.
Yeah.
So there are two key time points that showed up in both chronograms. One was 66 million years ago, and one was 27 million years ago. So like this has been happening a really long time.
Yeah.
Okay, so the 66 million years ago one. Fungus ant farms likely originated about 66 million years ago, around the same time a giant asteroid collided with Earth. So pretty cool. So this asteroid collision, as you might know, was what caused the extinction, or at least in part caused the extinction of non-avian dinosaurs and many other organisms. The clouds of smoke and ash likely shut down photosynthesis for months, maybe longer, killing off a ton of plants. So this was a big extinction event. I think it was like 75% of species went extinct, something like that. It's likely that some ants at the time already had a loose association with fungi in their environment, but with nothing else to eat, they started to evolve a closer relationship. So at the same time point on the fungus chronogram, fungi appeared to have evolved the feature cultivated by ants on at least two different branches, which is really interesting because it suggests that symbiosis wasn't like a one-off success, but it seems to have emerged independently multiple times under those harsh conditions 66 million years ago.
Right.
It seems like higher agriculture arose about 27 million years ago when South American habitats were reshaped by the changing climate. So this was a period, it's another time where there was a big extinction. So it's called the Terminal Eocene event, and it had effects all across the globe. Up until that point, South America had mostly been covered in these really vast forests. And so during this event, those forests were broken up by expanses of dry grasslands. You no longer had this like super moist environment. And so the researchers think that ants trying to adapt to the changing landscape carried their fungal cultivars to new colonies, which totally isolated the fungi from their gene pool. And then over time, these fungi lost the ability to grow beyond the ant garden. So remember, like higher agriculture is like the fungi are fully reliant on their ants. Yeah. And so, you know, the coevolution of fungus ant farms is really complicated, more complicated than researchers had thought. Again, goes to show that you got to look at both partners in a symbiotic relationship to really understand how it evolves.
That's really cool that they were able to do that.
I know. It's really cool. The next Pixar movie? I think maybe.
Fungus Farm.
Yes.
That's really just like going through that level of work that they had to do on both the ant and fungus side is so cool. That they were able to like put it together like that. Like, it must have been so cool to see like this thing that was paralleled in both of their chronograms. The chronograms?
Yeah.
Yes, the chronograms.
Yeah.
That's
I know.
so cool.
And at that moment where you see the overlap and you're like, wait,
it's there.
And that's when the non-avian dinosaurs went extinct.
Yeah.
What's happening?
Yep.
Yeah.
Oh, that's so cool.
It's really cool.
Well, thank you, Sam. I am here with a question. Not a show and tell, but like also a show and tell, because I think questions are also very important in the show and tell world. And this is from listener Ben. And Ben says, fresh squeezed citrus juice has a shelf life that is very short. This is why the best cocktail bars only squeeze fresh citrus. Fresh orange juice tastes great, and then as soon as it ages over a day, it tastes the same as Tropicana. Why is this? Which is a great question. I felt personally attacked by it because we tend to buy the cheaper orange juice, and so I'm just like, that's what orange juice tastes like. Like, as far as I'm concerned, orange juice.
You're missing out, Deboki.
I know. I mean, sometimes we'll like get the good stuff, and you're like, oh right, that's
what orange juice can taste like.
Yeah, it tastes like an actual orange. So let's start with that. Let's start with the difference between fresh squeezed orange juice versus packaged orange juice. Fresh squeezed is the stuff that you get like straight out of the orange, while packaged is the stuff that you're more likely to get at the grocery store. It might be concentrated, pasteurized, or stored in like industrial conditions. And there's actually an interview in the New Yorker with Alyssa Hamilton, who wrote this book called Squeezed: What You Don't Know About Orange Juice. And so basically what Alyssa says, there's like a lot of processes that can strip flavor in juices that are from concentrate or even not from concentrate. And the big producers of not from concentrate or pasteurized orange juice will actually keep these juices in gigantic storage tanks. Like, I don't even know that you can call them tanks. They're like million-gallon tanks. And that's just to make sure that they have enough juice to sell, year round. Because like, obviously you got to make sure you have stocks of orange juice going forward. The juice could sit in these tanks for a long time, sometimes for as long as a year. So they have to actually prevent the juice from oxidizing. So they're stripped of oxygen through a process called deaeration. And this is apparently done by a lot of the big commercial juice producers like Tropicana. In that process, you can lose flavor. So to recover it, companies will use flavor packs, which are made from the chemicals that are found in orange essence and oil. And one of the compounds that you might find in these flavor packs is something called ethyl butyrate, which is found in high concentration, particularly in North American orange juice, because flavor engineers, which I think is an amazing jobs title, they found that American consumers really like the smell and associate it with freshly squeezed orange juice.
Our noses are tricking us yet again.
Yeah, and the flavor engineers, they're working together. So as far as what might be making fresh squeezed orange juice taste less delicious over the course of the day, there are a few flavor molecules that are like known to kind of give fresh orange juice its taste. They're like alcohols, hydrocarbons, esters, aldehydes. But the major compounds in orange flavor are things that include citral, limonene, alpha-pinene, ethyl butanoate, acetaldehyde, octanol. These compounds can also form off flavors during the storage and processing. So like one might make a clove flavor, another makes a kind of lilac-y smell. And the point is that none of them taste right in orange juice. And so that is what's leading to that off kind of flavor.
That is so interesting.
Right.
Huh.
Yeah.
Yeah, I would be so curious to see, like, to chart those different compounds in orange juice, like fresh squeezed orange juice, and just see when you start to see certain compounds go down and then all of these byproducts go up.
Right.
And then see if that, correlates with people saying, this tastes kind of gross now, or like, this is just tasting more like Tropicana to me. I thought this was fresh squeezed.
Right. And I'm so like intrigued by the fact that like we apparently really associate ethyl butyrate with like the flavor of freshly squeezed orange juice. Like I kind of want to know like how does that actually compare to real freshly squeezed orange juice? Like do you find it in the same level, or is it just like we've decided like like the way that a candle company will make something where you're like, I know that this is not what this actually smells like, but now my brain will forever associate the smell with this word because that's what I've been told. the smells like.
Yeah. This is the smell of fresh laundry. And I'm like, my laundry's never smelled like that.
Yeah, exactly. Thanks to Ben and Matt for sending in a Tiny Show and Tell Us, a bonus episode from Tiny Matters created by the American Chemical Society and produced by Multitude. And a big thank you to science journalist Ariana Remmel, who did the research for this episode, kind of twice in some ways, too.
Yeah.
And for sharing their experience with it, too.
Yeah, super research for this episode. Send us an email to be featured in a future Tiny Show and Tell Us episode at tinymatters@acs.org, or you can fill out the form that's linked in the episode description. We'll see you next time.